Good evening, respected participants. I hope I'm audible.
Yes, ma'am, you are audible.
Okay. So we are here to discuss about the few concepts that are commonly seen as a part of statistics in your main paper. That is the second paper, core paper. Okay, so I'm not sure whether all the members whom I am communicating with are were there in my previous classes as well. However, welcome you all to this session where we discuss about statistics for research. So my strategy, what I thought I would follow for this session is go through the question papers. Okay, I've collected almost all questions from past 4, 5 or 6 years. And I have, when I saw the questions, I found that they were more or less similar, very similar questions. So instead of me teaching you from the beginning what are the concepts, it will be better that we look at a question and discuss all relevant contents of that particular concept. Everything revolving around that concept, we can have a discussion on. Okay. Yeah. So let me proceed with the discussion. The first question, this was a question which was asked very recently. Assignment of numerals to the objects to represent their attributes is known as nominal data, ordinal data, interval data, or ratio scale. What is that data where objects are assigned numeric values? Excellent. Yeah, that's correct, Dr. Divya. That's called nominal data. So you might have already seen that in research methodology that is called as nominal data. Then let's just have a look at what is ordinal, interval, and ratio data as well. I hope all of you are aware of it. That I think I reached the second slide. Okay, one moment. Yeah. So what we mean by nominal data is naming variables. Whenever we have naming variables, they are called nominal data, like religion or our mother tongue or nationality, qualification, company which we work. All of it falls under nominal data. And if you want to assign a number or code, suppose a company name, you are coding it using numbers just for the sake of convenience. If you are coding it, then we can call it as, then also it is nominal data only thing it assigns numeric values. Ordinal data is a data where we have rank or the order of the numbers matter. Okay, ordinal data is where the number order matters. Order of the number matters in the sense, if you assign the rank, it's like, assigning 5-star hotel, 7-star hotel, like that numbers signifies that particular value. It has a value since it is in that position. Okay, that is what is ordinal data. Most of the time ranking, if you are asking somebody to rank the preference of some of the restaurants or some of the investment options, then we call it as ordinal data. In fact, our Likert scale is an example of ordinal data. The Likert scale, where we say strongly disagree, disagree, neutral, agree to strongly agree, or little more classifications, highly satisfied, satisfied, less satisfied, and then neutral. It's okay. So you may have 5-point scales, you may have 7-point scales. However, whenever we are considering these kind of data, whenever we are having these kind of variables, we we happily take them as interval scale data. Actually speaking, strictly speaking, they are ordinal scale data, because that order has a uh, value in it. Maybe ascending, maybe descending, but it has a value. Moreover, either you cannot do any mathematical operation on that kind of a data. You cannot add them, you cannot divide them. It makes it meaningless. Okay. So that is the reason why such kind of data is also called ordinal data. But for sake of convenience, we consider them as interval data and work. Interval data's best example is temperature, where there is no specific zero. When you say 0 rupee with you, you mean nothing. There isn't anything with you. But when you say 0 degrees Celsius, it is not that there is no temperature. There is temperature. It is coded. Okay, it is coded as 0. That's how we need to consider. So interval data are numbers. Okay, they are always numbers. Only thing, they don't have an absolute 0 with them. And Likert scale most of the time is considered as an interval scale data. Then the fourth one is ratio data, which all of us know that every measurable variable comes under ratio data, like your salary, age, everything, height, weight, exports, imports, all of it comes under ratio scale variable. Okay. And then proceeding, coming to a graph. Okay, can we proceed to the second question? A graph of cumulative frequency distribution is called, what would be the definition? I mean, what would be the name of a cumulative frequency distribution curve? It is called an ogive. Okay, ogives or cumulative frequency curves are those frequency curves which are plotted using cumulated frequencies. Okay, so cumulated frequency graphs are called ogives. There are two types of cumulative frequency curves. I'll skip from this mode because I can also, why am I not? Yeah, I can also write a little bit if I'm not on the screen share mode. Yeah, so when we talk about ogives, if at all a possible question that can come from ogive is, what are ogives? So I hope you understood what is ogive. Okay, ogives are cumulative frequency graphs, cumulative frequency curves. Okay, they are similar to, they are similar to the they are actually similar to the graphs or values, wherein only difference is that we are taking cumulated frequency. So there are two types of cumulative frequency curves. One is less than ogive and one is greater than or more than ogive. Okay, greater or more than ogive. Okay, then another question that can be, or that awareness would be good, another question or an option that would be possible, would be helpful for us is, I hope you know that the shape of the graph would be like this. When you say a less than ogive, it generally takes the shape of a less than, a kind of a less than shape. When you plot it on a graph, the less than ogive takes somewhere the shape, it opens towards the right. When you talk about a more than ogive, it will have, a symbol, I mean a shape from here. It will start from the topmost frequency and it will fall down to a lesser value. Okay, so this is more than cumulative frequency, and you can see that the shape would be kind of more than. Okay, so that is about ogives. And there are two measures of central tendency that can be obtained graphically. Okay, I am just revolving around that question and trying to convey every possible questions related to ogives and other graphs. Okay, two measures two measures that can be located graphically are, two measures is two averages. Okay, they are, one is median. Median can be plotted, can be obtained using ogives. Okay, you can find the value of median using ogives. Second one, what you can obtain as a positional average is mode, for which you require a histogram. Okay, from a histogram we can obtain what is mode, and from ogives we can obtain what is a median. Okay, so I'm sure all of you would remember, you plot both the ogives, and then from the point of intersection of the ogive, if you drop down a perpendicular to the x-axis, you get the value of median over here. Okay, that's how we find median, the value where the perpendiculars meet. But we don't have to go to those details, let it be. Okay, we don't have to definitely go to all those details. Only thing you should be aware of, which are the values that which are the measures that you can locate graphically among the three main averages, that is arithmetic mean, median and mode. Median and mode are called positional averages, and they can be located graphically. Their position would be fixed, only the value which appears there might change. That is why they are called positional averages. The mathematical averages are arithmetic mean, geometric mean, and harmonic mean. Okay, fine. So let's get back to the question. Where were we? We were discussing about the first question. Second question is done. So the answer to this question, I hope you have understood, it is 3. Okay, here the answer would be 3. Answer is 3 for the second question. Yeah, and for the first question, already you know that the answer is A. Fine. Let's proceed to the next question. Moreover, I also wanted to tell you what are the other graphs. Among the graphs and charts, frequency curve and frequency polygon is just a frequency when you're plotting the frequency. Mainly we find charts. Mainly we find charts used when each chart is applicable is a topic that is familiar to all of you. Still, let me try to quickly convey what it is. When you want to explain what is the contribution of each sector to 100%, or the other way around, what each how the 100% gets dispersed among a group. Okay, so when you want to know how this 100% is getting distributed among a set of values, we can use pie chart. Pie chart is the best representation when you want to see how the entire thing, when the total is getting distributed into different parts. Whereas instead of this, bar charts are also seen common. Okay, bar charts also represent more or less a comparison of this. If you have multiple things to be compared, we cannot use a pie chart. You will have to use a bar chart only. Like, you know, there are three attributes to be compared. You want to compare furniture, at the, office supplies and technology. So central, east, south and west. If you want to make a comparison, you can make a comparison across. You can also make a comparison within the central also. Okay, so thereby these kind of comparison is best using a bar chart. When you have time upon one variable, best is using time series graphs like line graph, time graph. Okay, again, instead of time graph, bar chart is seen, popular, very commonly seen. Okay, fine. If there is any query related to any of the topics that we are discussing or somewhere around what we are discussing, kindly put it into chat box, or I think you can even unmute and talk. I'm not very sure whether that is available. Otherwise, please put it in the chat. Let us discuss it then and there. Okay, instead of piling up the questions towards the end, it is always better that we complete it then and there. Okay, yeah, proceed to the next question. Okay, so in this question, the event of interest A, if the event of interest is A, then which of the following statement is correct? Which among the following statement is correct for an event A? First statement, the probability that A will not occur is 1 minus P of A. The probability that A will not occur is the probability of complement of A. The probability that A will occur is 0 if A is an impossible event. And last one, probability that A will occur is 1 if A is a certain event. And E, all of the above statements are correct. Can you give your answers? It's a very simple question. I think, yeah, I think Dr. Ravindran has given the answer as A for a previous question, and probably this one is E. Dr. Vidya has correctly said the answer. It is E. Okay, so these are all the properties that we need to remember whenever we are talking about probability. One is that complement is 1 minus probability of the event. So first and second statement, A and B are the same. A and B conveys the same thing. Okay, complement of a probability is not occurring of a non-occurrence of an event is called complement of an event. Okay, then probability of an event is 0 when it is impossible event. Fine. When for example, if you consider the in a dice tossing experiment, what is the probability of 7 turning up? When a dice is tossed, what's the probability of 7 turns up? 7 cannot happen. 1 to 6 only are available in a dice, right? So that is what we mean as an impossible event, right? So in an impossible event, the probability also is 0. Then probability of A, if it is sure to occur. Now, if I say when a dice is tossed, what's the probability that a number between 1 to 6 will occur? It's a sure event, right? So sure event is, certain event is probability 1, total probability is 1. Okay, so apart from this, the other points that you know are that value of probability always lies from 0 to 1. It should never exceed 1, nor it should fall below 1. Okay, so the answer to this question, this was, I think, last year's question paper question. That's why I couldn't copy it as such, and it came as an image. So I'm actually not able to write the answer here. I hope you have taken a note of it, that here all the above statements are correct for this question. Okay, all the above statements are correct in this case. Fine. Proceeding to the next one, which of the following definition is correct? Which of the following definition is correct? An activity which results in an outcome is called an event. Secondly, the probability of an event is expressed in decimal form ranging from -1 to +1. Third option, the sample space refers to all possible outcomes of an experiment. Which is correct is the question. Which is correct is an experiment. Okay. Many of you are giving the answer as A. In fact, the answer is C. The answer is not A, answer is C. An event, outcome, activity. An activity which results in an outcome is called an event is not correct. Outcome and event are more or less same terms. Okay, they are the result of an experiment. Outcome or event is a result of an experiment in terms of probability. Outcome or event in terms of probability is the result of an experiment. Like when we toss a dice, uh, what is the outcome of it? So outcome can be 1 to 6, any of the numbers. We can also define them as events 1 to 6. Okay, so activity doesn't come under the purview of probability. That is why first statement is not correct. I hope it's convincing. Okay. Whereas second statement, we know that the range of probability is 0 to 1. Sample space exactly is defined as set of all possible outcomes of a random experiment. Set of all possible outcomes of a random experiment. If there is any clarification on this slide, please you may unmute and talk, or you may put it in the chat box so that I can explain it further using a whiteboard. Otherwise, I hope you have understood that first question's answer is E and second question's answer is C, and I have justified why the answers are. Hope I can proceed since I am not finding any queries coming up. If at all it is there also, now also you can give it. Trust me, these are questions that were in the previous years, so don't take it lightly. They are very simple concepts. You can always answer easily. So don't leave it. Probability will never be a difficult question. It will be a very easy question. Yeah, since there aren't any questions, let's proceed. A committee of 6 people is to be formed from a group of 7 men and 4 women. What is the probability that the committee will have exactly 2 women? Committee of 6 people is to be formed. Committee of 6 people is to be formed from a group of how many altogether? Men and women put together, how many are there? 7 plus 4, 11 people are there. Okay, a committee of how many are to be formed? 6 members are to be formed. Fine. Now, in that committee of 6 which we are selecting from 11, what is the probability that there are exactly 2 women? That's a question. Okay, I hope the question is clear, and can I get some answers? Okay, can I explain? Whenever we are taking more than one element from a group, you need to use the concept called combination. Okay, if it was just one person selected, if it is 1% selected, this may be new to few of you at least. That's or else you might have forgotten. It may not be new. You might have forgotten. So I'm just writing in. Just 1% selected means it can be directly. How can you have one woman out of 11? It will be directly favorable by. We know that probability definition is given here. Probability is defined as number of cases favorable for number of total number of cases. So here it can be directly total number of women 4 divided by total number of people over there, 4 by 11, if it is just 1% selected. Now that there are many people, I mean there are 6 people to be selected, we have to use the idea of combinations. We will have to use the idea of combination. Okay. Where Yeah, so when it comes to combination, the meaning of combination is that you can select totally from 11 members, you can select a combination of 6, 11C6, all possible combinations of 6 from 11. So the denominator, this is the total possible cases. Total possible cases is 11C6. Okay, what is favorable for women, favorable for 2 women from among 6 women, from among 6 women, how do I get 2? That will be from 6. I am trying to get all possible combinations of 2. Suppose I am calling the women as A, B, C, D, E, F. So my combination, by the term combination, I mean AB, AC, AD, AE, AF, BC, BD, BE, BF, CD, CE, CF, DE, DF, EF. This is the meaning of combination. Okay, so I hope I've explained it kind of okay. Now let me erase all this so that space will be sufficient for us. So let's proceed to the answer. What is it? Favorable cases is 6, combination 2, that means all possible combinations of 2 from 6 on 11C. How many we need? We need 6 from the total. Am I correct? Sorry, 4 women only. It's not 6. There are only 4 women in all. There are only 4 women from among the 4 women. I missed it. Sorry, I mistook 4. Instead of 4, I took, yeah, from 4 women. Sorry, 7 plus 4 is 11. Yeah, that is why this 11C6. From in this 11C6, I want to have 2 women. Okay. Now, how do I simplify this? Simplifying is also easy. 4 into 2 divided by 1 into 2. Okay. Forget about those definitions that we have learned earlier. Start from 4, come 2 steps down. 4 into 3 and 1 by 2. 4C2 is 4 and 2 terms down. 4 and 3. 11C6 is a little lengthy. It will have 11 into 10 into 6 terms will have to come. Okay. 11, 10, then 9, 8, then 1, 2, 3, 4, 2 more, 7 and 6. Okay. This is the numerator divided by all denominator is 1 to 6. So 1 into 2 into 3 into 4 into 5 into 6. Okay. So many terms will get cancelled here. Nothing to worry. Most of the terms will get cancelled here. So what would be the result after the cancellations? Numerator will just have one term. What is it? 4 into 3 by 1 into 2 will be 6. Because this 1 and 4 and 2 will get cancelled. Numerator will be 2. So numerator is 6. How about 11C6? Most of the terms will get cancelled. Most of the terms over there will get cancelled to give us, let's see, 10 and 5 will get cancelled. This will become 2. Okay. This will turn out to be 2. So this 5 disappears over there. Then what else? 2 and 2 will get cancelled. Okay. Let's take the 6. 6 and 6 will reduce by itself, right? There are 2 terms of 6. So 6 and 6 cancels. Then 4 and 8. 4 and 8 cancels to give us 2. Okay. Then this 2 and 2 gets cancelled to give us 1. Then 3 and 9. Yeah, that's nice. Every term got cancelled. 3 and here it is 3. Okay. So that's all. 2 into 3 into 6. 2 3s are 6. 6 into 7 is, so ultimately we are left with just 3 numbers. 11 into 6 into 7. 6 sevens are 42, right? So we know that any number when you're multiplying by 11, it will be easy to write. How will it be? 4 and the addition. Control C and then yeah. So here the denominator will be 4 and 2. Write them apart and add and write it. So it is 4, 6, 2. Okay. Addition of those two numbers should come in the middle. We are aware of multiplication by 11. 2-digit multiplication. We know, we have seen it earlier also. And then we need to find the answer for this. Okay. So it has to be none of the above, definitely. It should be none of the above because there isn't even 50% of it. Right? 6 by 462 is not even 60% of, not even 50, nowhere 50%. Is there a 50% value? No. It will be 0.0 something. So the answer has to be none of the above. Don't take time to solve it. Directly write the answer, because unless it is somewhere close to 200 odd, you are not going to get. Okay. One moment. I've made a mistake here. I also have to write about the remaining 3-4 members. I should say that. Okay, when I say this, here I will have 2 women and remaining 4 men. Oh, I forgot about one term totally. I'm sorry. This is incomplete. Okay. Along with this, I should also have and is always going with the multiplication. And from how many men? 7C 6, 7, C, 4. This also should happen. Now, this is another point in probability that you need to remember. Even if we are talking about only 2 women of the group, we have to specify about the remaining 4 people. When we select 6 from a group of 11, we are specifying about 2 women. So what should be the remaining 4? They have to be men. Even though it is not spelled out in the question, we have to say it. Okay, we will have to write it. That is, so let us put it here also. How will it be? 7C4 will be 7 into 6 into, I hope you understood how I am writing this logic, into 7 6 5 4, 4 steps down. That's how it goes. And here it will be 1 into 2 into 3 into 4. This is how we generally. So you can see that this 4 and 4 will get cancelled, 6 and 3 will get cancelled, right? Many terms will get cancelled. So let us simplify and write it here a little more. Into, on simplification, I'll quickly do it in a paper, that is better. Okay, because simplification might affect you. So 6 and 3, 7 will remain there. 6 and 3 will give us 2. 4 and 2 also will give us 2, and there will be 1. 4 and 4 gets cancelled, right? So 6, 7 into 6, 7 into 5, that's all, 35. Okay, 6 into 35. 6 into 35. Yeah, now we can say what will be the value. Again, please don't go for a calculation. Okay, directly say the answer. It has to be 0.45, because it cannot be the other 4 numbers. Okay, a little bit of division if you want, you can do. It should be 0.456. So the answer here is going to be A. Okay, the answer is close to 50%, but not exceeding 50%. So the only thing what you have to check is the first 2 decimal places, whether it is coming on division. Okay, so here the answer is A. So I hope I have explained little bit about how to calculate probability. I took this question because it was somewhere 2013 question, or for 17's question. Okay. Now, when it comes to hypothesis test, okay, when we proceed to hypothesis test, and I'm sure all of you are also aware about the hypothesis testing. What is alpha and beta? Okay, for a test of hypothesis, what is alpha and beta? How do we define? If alpha is 0.05, beta is 0.01, the power, what is the power of the test? Can I wait for a moment for an answer? I hope all of you remember what it is. Okay, let's proceed. Power is the probability of answer is 0.95. No, Professor. The answer is 0.990. Power is 1 minus beta. Power is 1 minus beta. Okay. If you all remember, there are 2 types of errors in a null in testing of hypothesis. One is type 1 error and type 2 error. Type 1 error and type 2 error are the 2 types of errors. So when we talk about power of a test, it goes with type 2 error. Okay, type 2 error is beta. Beta is called type 2 error. Okay, the complement of type 2 error is power, correct conclusion of rejecting a null hypothesis when it is actually false. Rejecting a null hypothesis when it is actually false. Let me quickly write it here. Okay. So what we mean by, let me erase all the drawing here and then type it fast. So we know that alpha is the probability of accepting, no, rejecting a null hypothesis, it is when it is true, a true null hypothesis getting rejected. Okay, that is what we call as alpha, which is we generally call as level of significance. When it comes to beta, beta is that is type 2 error. Okay, probability of beta is the probability of accepting a null hypothesis which is false, null hypothesis which is false. Getting it? The complement of this is called power. Power is the probability or the ability of a test. Okay, this is probability of rejecting. It is a good quality of a test. Okay, rejecting a null hypothesis which is actually false. Okay, so this is actually a correct decision also. It's actually a correct decision. Okay, it's a correct decision, and larger the power, better the test hypothesis is, better the test. Okay, and you need to understand one more point, that is never assume that alpha plus beta is 1. Okay, alpha plus beta is not 1. Okay, is not 1. Never assume that put together they will happen. It is not like that. Okay, alpha, complement of alpha is 1 minus alpha. That is totally different. You will not take all the decision together. Okay, you will take, either you will reject a wrong null hypothesis or you will accept a wrong null hypothesis. That's all. You cannot have 2-3 decisions together. Okay, alpha plus alpha's complement is 1 minus alpha. Okay, similarly you have beta and 1 minus beta. Okay, beta is the probability of type 2 error, and power is probability of its complement. So beta plus power is 1. Beta plus power is equal to 1. I hope I have explained it, and it's fine. Okay, if you feel I need to go faster or I need to explain anything else, please let me know. Otherwise, I hope it's conveyed. And can we proceed? Yes. Okay, there aren't any chats or answers, so let me proceed. Okay, we are proceeding to the next question, which was also asked once. The question is like this: from the following ANOVA table. Okay, usually we know, all of us work with softwares, so ANOVA table generally is provided like this. It will have 3-4 columns. One will be sum of squares. Okay, one of the column will be sum of squares, another set of column will be degrees of freedom, right? Degrees of freedom, and then you will have the F statistic and the p value calculated. This is how it goes, right? So what is it? What is it all about? How do we calculate it? I hope you all remember all these calculations which we have done during our postgraduate studies. How do we calculate the F value and select the correct answer? Any idea? When we proceed with this kind of an analysis, we would be taking the calculation based on, let me take you to the next slide, which will give us the calculation formulae. Okay, so let me take you to the next slide. This would probably give you a better idea about how it is calculated. Okay, one-way ANOVA or a two-way ANOVA. The calculations are based on an F statistic. Okay, the calculations are based on an F statistic when it comes to analysis of variance. Okay, so in this analysis of variance, we have something called mean sum of squares and error sum of squares. Okay, so that's the total variance explained by the model and total and the remaining. Okay, that's how we usually work with. So in this example, you may just observe that this is an example of two-way ANOVA. You might have already noticed that it's an example of a two-way ANOVA. Correct? It's an example of two-way ANOVA. It is not one-way ANOVA. It's an example of two-way ANOVA. Okay, when it comes to a two-way ANOVA, we have to take both of these variations, and we will also have to calculate what is the error sum of squares. So we have to do a little bit of calculation over here. How to proceed with the calculation? Let's see. If it is when here we are having a two-way ANOVA. Okay, so in this two-way ANOVA, mean sum of squares due to error, mean sum of squares due to column, mean sum of errors due to row, all of it are to be considered, right? So we have sorry, this is the question that we were discussing. Yeah, so we have the total and we have the rest of the numbers. There isn't any error that is given at all. There isn't any the deviation that is given due to error. Okay. I strongly feel that, you know, this is there was an error in this question, because we cannot directly find the answer like that. There is a small error in this, in the sense there should all total variance will not be all put together. Yeah, yes, Dr. Vidya. If row and column means, it actually means two-way ANOVA when both row and column are given in the study. If it is only one of it, if it is only row wise or if it is only column wise analysis, then we call it as one-way ANOVA. Okay, now that there are both of it, there's a small error in this calculation. In fact, okay, the error goes like this. You should also have the ANOVA table based on source of variation due to error. Okay, so not only this, in a few other questions also, I observed that there are a few problems, and never our total calculation will come to 100 directly. There should be some value over here also. Okay, I'll just see what is the answer that was given. It was given to be A. Okay, so A, if they have calculated it as A, it is basically, you know, the denominator of it is missing in this question. The denominator part of it is missing totally. Okay, why I brought this question is to show you that there was once a question of this kind which was actually not correct. Always there should be error sum of squares. Let me show you the actual calculation. Whenever we have an ANOVA table, I'm sure all of you all would have already seen that it should have, you know, see, like this, between group. This is an example of a one-way ANOVA. This is an example of one-way ANOVA. We can apply two-way ANOVA formula. We can apply two-way ANOVA formula provided, yes ma'am, we can apply the formula for two-way ANOVA, but the two-way ANOVA formula should also require something called error sum of squares. Okay, because always for this ratio or the F statistic, the denominator is error sum of squares. The meaning of it is, yeah. Yes, ma'am. So the meaning of it goes like this. Whenever we have, let me try to annotate here. Where is it? Okay. Okay. Fine. I'm not able to write here. However, let's try to understand what basically ANOVA. What is the problem with this question was that, yeah, when it comes to a calculation, when you say about any specific calculation or ANOVA, when we say, if you have a source of variation, say for example, you are trying out with any specific detergent, you are trying whether 4 salesmen are having the same or equal sales, you are trying to see that whether 4 or 5 investments have the same average. So the variations due to investment is one option. Apart from the variation due to that particular factor, there may be other factors also. So all other factors are called errors, right? So there should always be something called treatment, one or more treatments, and the leftover, whatever we have not explained, is called error. Okay, and we always take a definition of F statistic to be, F statistic is a ratio of, okay, treatment sum of squares, or the variation due to a particular source, variation due to treatment. The treatment can be one or more. The treatment can be one or more, in the sense it can be row wise and column wise together. It may be only row wise and only column wise also, like one-way ANOVA. Okay, divided by variation due to error. The meaning of error is not that of that English error. Here the meaning of error is what is not explained. Okay, variation due to error. This error term is totally missing here. Okay, and why I said there is an error in the model is that I'll just come back to it. Error we cannot find directly. Okay, error is calculated as total minus treatment. Total minus treatment. Okay, if it is one-way ANOVA. If it is two-way ANOVA, then we will have error. Okay, error sum of squares. Okay, we'll come to that column. Error sum of squares will be from the total. We will have to deduct row wise whatever is the sum of square and column wise also. Okay, so this difference has to be more than 0. It has to be more than 0. Otherwise, what will happen? Denominator will turn out to be 0. And division by 0 is not defined. That is the reason why I said there is an error in this. There is an error in this question. You can see that error is not at all mentioned. And the total of row plus column is coming to 124. That shouldn't happen. If error is 0, that means there is no unexplained variation. So here there is a problem with the question. Okay, they might have taken care of it somehow. Anyway, I will not be answering this question and I will not be considering the answer as A. It is definitely error in the question. There is something went wrong in the question. Instead of that, we can consider another question that I have given here. Suppose you want to find what is the F ratio, that's a statistic value over here. So you can see that source of variation, there are two of it. What are they? Between and within. Between and within. That means between group is what we call as treatment. Okay, this between group is what we call usually as our treatment. Due to whatever we are studying, that is called between. Within the group also there will be variation. This is what we call as error sum of squares. Okay, and then we can use these two for our calculation. So what is it? The value will be sum of squares. Okay, directly see mean sum of squares of treatment divided by mean sum of squares due to error. Straight away we can write it here as 3. Okay, I'm sorry, number lock. Yeah, 3 here let me write it as 9078.066 divided by 3997.1. This is how we will be calculating. Okay, I hope I explained it. I'm not sure whether I confused you. Mean sum of squares due to treatment divided by mean sum of squares due to error. So error, unless error is defined, it is not fair to calculate. Now the way we can consider it is that instead of row, you may consider this as error. If that is the case, we will have to find what is mean. That is 100 divided by 3. That is mean sum of squares in the numerator. 24 by 16 will be the denominator. If at all you want to calculate, the best what you can do here is 100 divided by its own degrees of freedom. Okay, 100 divided by its own degrees of freedom. The entire thing is again divided by denominators, that is 24 divided by 16. Okay, so both cases you get 33.33 and denominator you get 3 by 2, that is 0.66. Okay, so you get a value somewhere, maybe. This is the worst scenario answer for it. Worst scenario if I am considering row as error. Okay, it's actually not at all correct to go with it. Fine. Let me proceed. I am not getting any chats or queries, so I'm proceeding. Assuming that I'm making sense out of it. Let me see if all my participants are there. Nobody has ran away. Yes, all are there. And they are very quiet. Maybe because I have made it tough, or is it familiar to you, or any other reason, please let me know. We are discussing questions that were previously asked. And what is the requirement? Why do we have to do ANOVA? ANOVA is a parametric test which is used to compare 3 or more averages, 3 or more means. Okay, back to ANOVA. ANOVA is a test which is a parametric test which is used to compare 3 or more averages, 3 or more populations and their averages. Okay. There are two types of ANOVA basically, one-way ANOVA and two-way ANOVA. There are furthermore, there are lots more. ANOVA is just the base to start with for any student. Okay. Fine. Then proceeding to the next question. Proceeding to the next question. I hope I have not unmute. Yeah, I'm not on mute. Yes. This is a question. Find the chi-square value of the data. Find the chi-square value of this particular question. Events and expected. What is the correct answer? Find the chi-square test statistic. Again, if you remember, I've given the formula for calculation. O minus E by E the whole square. This is how we calculate chi-square test statistic. It's a very easy formula. O minus E square by E, summation O minus E square by E. Now, what is O? What is E? O are these values, whatever is observed. This is O. 40 is another observed value. 52 is another observed value. And 48 is another observed value. We calculate, the question had only those. The question had only those many. What I did? I found the row total and column total. This is the row total, 112 and 88. These are the column totals, 100 each. Okay. So how do you calculate this value is the formula for it. If you want, if you have time, you can calculate it. Otherwise, directly also we can calculate here itself. Okay. So how do you find E values? E we will have to calculate, no choice. Okay. But it is easy in this scenario. What is the expected value of 60? Take the corner value 112 and the row total value, column total into row total. Okay. So this is the column total and this is the row total for 60 RT, row total for 60, correct? Row 60 is row total and 60 is column total divided by grand total. So 112 into 100 by 200 is 112 by 2. So it is directly 56. We don't have to do any calculation there. That's how this 56 has come. Got it? Is it fine? Next one. Next one, 52. How do I get the value of 52? 52 row total divided with this 52's corresponding column total. Thankfully, here again it is the same. PT, column total remains to be the same for 52. Okay, for 52, it is 100. Row total is 112. Again, the answer is 56 itself. Yes. And next would be 40. For observed value 40, what do we expect? If there is no relation between the row and column, what is expected? That's the meaning of it. So it is 88. That is a row total. Row total now shifted, right? Because now we are in the second row. So 88 into 100 divided by 200 is obviously 88 by 2. That is why this is 44. And last value for 48. This 48 here now. Previously also it is this CT, column total. So that is also 44. Now the difference between them is 4. See, it is throughout 4. Need not be the case every time. Here it is positive, negative, 4s. Okay. Then what we have to do is we have to square them and divide by E. So what is it? 16 by 56. It actually comes like this. The calculation is where can I type? Let me see if I can type in somewhere. No, it is full of tables and figures. So I'm not able to type in anywhere. Probably I can take another tab and type in. So the calculation is like this: 16 divided by 56 plus next O minus E square is again 16. 16 divided by E. 16 divided by the corresponding value 56 plus next value 16 by 44. 16 divided by 44 plus I see that one of the values have turned out to be 44, right? Observed value 44. Corresponding values. Plus. Is it fine? Have you understood how it is? This is how the calculation should happen. So when we add them and divide them, so it is actually 32 by 44 plus 32 by 56. Then we can get a total of it. Okay. In fact, the value comes out to be somewhere 1.33. when you add them. You can add it and divide, or else directly also you can go with it, because you have the same denominator twice, right? So it is 32 on 56 plus second term, 16 plus 16 again 32 on 56. Okay, so these type of questions I will always suggest you to go at the end, if at all time permits, go for all these kind of calculations, because they take time. They are obviously time consuming. Okay, so the question was to find which is the answer among the options, 1 point, 2 point, 3 point, 4 point. So roughly we can calculate first decimal place itself and then go with it. Okay, okay. So I'll just disclose answer and then proceed. Yeah, okay. And I have shown you how that 1 point is appearing. Either way, if you have time, you can calculate one by one like this, 16 by 56, then 16 by 56. Okay, the columns that are used are this one, no highlight option. Yes, and this one. Fine, let me proceed. Let's proceed to the next question. Yeah, what are the possible classes under consideration of, if there are 8 possible classes, sorry, if there are 8 possible classes under consideration, if there are 8 possible classes under consideration for goodness of fit, the number of degrees of freedom will be, goodness of fit is also a test that is basically used, which uses chi-square, okay, and the degrees of freedom is generally 1 less than number of classes, 1 less than number of classes. Okay, if there are 8 possible classes, usually it is a chi-square test. It is usually a chi-square test that will be used. Okay, usually it is a chi-square test that we will be using. Okay, which will be a chi-square test that we'll be using for goodness of fit. If we are using that chi-square test of goodness of fit, then we will have degrees of freedom to be k minus 1 for number of classes. Okay, number of classes minus 1 generally. Okay, number of classes minus 1 most of the time. The meaning of goodness of fit is, you are trying to say that, you know, the ticket booking across the week is uniformly distributed. Ticket booking on flights or maybe railway, whichever, or even it's for films, the ticket booking goes on a uniform rate. If I'm suggesting, uniform is a model over there, uniform distribution of data is a model that we are considering. So is it actually true? Does uniform distribution fit into this data? That is a scenario in which we are talking about goodness of fit. The meaning of goodness of fit is how well does a model fit into a data. Okay, it need not be like that. It can even be you know, your multiple regression model, whether that fits in well into a given data. You have fit a linear model. What is the goodness of fit? Okay, chi-square is a general test that is used for it. Many times you can also find ANOVA to be used as a test for goodness of fit. Okay, these two tests are used at definite contexts. I cannot say they are interchangeably used. Never they are interchangeably used. ANOVA is a pure statistical, parametric test. Chi-square is a non-parametric test which goes with count, which goes with frequencies. Chi-square is a non-parametric test which goes with frequencies, which goes with count. ANOVA is a parametric test which goes with average, which goes with specific parametric calculations only. Okay, fine. Then proceeding to the next one, that is next question. I'm not sure that if I'm not getting any chats or queries, is it because I'm not very clearly explaining, or is it because you are able to follow? If there is anything, please discuss then and there so that it will be useful for us. Maybe don't think that any doubt is trivial. There aren't any easy doubts. There aren't anything that is simple. Doubts are to be clarified if at all there are any. Yeah, time series is a set of data collected at random intervals, regular intervals, convenient intervals, all of the above. This I'm sure everybody will know the answer. Let me wait for an answer. No, you can't have random intervals and then call it time series. Time series should go with, yes, B is the answer. That's correct. Professor Joseph has given it the correct answer. Given the correct answer. Regular interval. A time series should not have a random pattern. Then you can't even plot. You cannot understand the pattern, right? You cannot take any information from these kind of data if it is not on a regular interval. So it has to be on a regular interval for sure. Okay, so the answer for it is B. Okay. Time series is a series which is indexed with time. That's how we even consider it. Okay. Time series is a bivariate series. Usually we consider time series as a univariate series. No, you can even consider it as a bivariate series. My spelling of series went wrong. That's fine. You can consider it as a bivariate series where our independent variable is time. It's fixed. Independent variable is time and it is fixed. Okay. Independent variable is time and dependent variable is the variable under study. Getting it? So it has to be at fixed levels. Only then we can reveal the various. Now the other points that you can remember that you need to know about a time series are what are the components of a time series. Since there was a question on time series, we'll just see what are the components of a time series. They are called the trend, then seasonal variations, which are like, which would repeat within a span of an year. In 12 months time, you will find, or even lesser span of time, you find those patterns to repeat, like, more investments for tax saving. That happens when it is time for us to, file the returns, or when it is time for us to, when the office asks us to give us our plan. That is where then we'll forget about it, right? Another, or else, the time when we purchase all these kind of things, when we purchase various what do you call stationery for school, unlike, in an year of this kind. Like another value is cyclical variations. Cyclical variations are variations which also recur, but doesn't recur over shorter interval like 1 year. It will take a longer period of time, like 3 to 4 years for the same pattern to appear. Okay. And then comes the random pattern. The best example of random pattern or the random component of a time series is what we are experiencing right now. Very unexpected and very random, which has affected every time series. It would have affected the tourism industry, stock market, any industry, any time series you check, you will find a lot of variation from the previous patterns. Okay. So those are the 4 components of a time series. And these 4 components might come as an addition. Any value in a time series may be an addition of these 4 components, or it can be a multiplicative effect of these 4 components. Okay. So according to whether it is additive or whether it is multiplicative, the model becomes linear or exponential. Example for time series. Example of time series is, the footfall in a mall during weekends. If I am taking every Saturday and I am checking the footfall in any specific mall, that forms a time series. Stock market data, I am taking it on a daily basis, monthly basis, weekly basis. It is called a time series. Okay. Population of a country over every decennial data. See, our census data that is collected, that is not exactly a time series. That is called a panel data, because there are multiple variables which are collected over regular intervals of time. Okay. So the other way of collecting data other than time series is called cross-sectional data. Time series data, cross-sectional data, and panel data. These are the 3 types of data which are very common in the case of the types of data that are used generally apart from time series are, what is it called? Uh, Time series. Then we have cross-sectional data. Okay, most of our data that we collect using our what is it called, questionnaires, interviews, etc. That doesn't happen over a long period of time, right? Cross sectional data is collected at a specific time point, okay, at one time point. That doesn't mean 1 day or 1 hour. It can be in a month's time, in 2 months time you collect data. That is called cross sectional data at one time period. The time period can be short, the time period can be long. That's called a cross sectional data. Instead, if you're collecting time series data is also called longitudinal data. Okay, longitudinal data. What more we need to discuss about time series? That's it, I believe. Then there are various methods to extract all these components. That's fine. We don't have to go. I never saw any question more than this. Okay. So along with time series comes the bivariate details of what is it, how, what calculate given the following. One moment, let me take out something that we don't require. Yeah. Okay, so, and then let us see what is it here. Okay, given the following data, calculate the regression coefficient. Yes, calculate the regression coefficient of x on y. Pearson's coefficient is given. Regression coefficient of y on x is also given. Given the following data, calculate regression coefficient of y on x. Okay. So how do we calculate the regression coefficient of y on x? Yeah, when you are given the data on the other regression coefficient. Okay. Let's see the formula. We might have forgotten the formula. So in the formula kept here. Yeah, I don't know why it's not popping up by itself. Yeah. Yes, ma'am. One-time data calculation is called cross-sectional data. That one time can be 1 day's time, 1 month's time, 3 months time, however, but we are not considering the time period, or say we are not indexing it with like Saturday it happens, Sunday this is happening, or this particular date this is happening. When time is not our concern, it's called cross-sectional data. That's it. As simple as that. Yeah. Now, how do we calculate? How do we calculate for our question? Yeah, for that it is good to know what is the relation between correlation coefficient and regression coefficients. It is always good to know the relation between correlation coefficients and regression coefficients. Relation between correlation and regression coefficients. Okay, so you can see here coefficients. INTS. Yeah. What is it? Bxy and Byx are regression coefficients. The square root of their product is correlation. The two regression coefficients, I'm sure all of you are aware that they're in a bivariate scenario. That means when you consider only two variables, okay, in a bivariate scenario of x and y, there are two regressions. One is called x on y, second is called y on x. Okay, x on y and y on x. So that is when x is depending on y, second one y depending on x. So when we have these kind of regression coefficients with us, when we are considering both, the relation between them is defined like this. Product of the regression coefficients under root is R. So back to the question. The question is like this. One of the regression coefficient is given. Y on x is given. Correlation is also given. Okay. So when we substitute, one of the regression coefficient is given. Correlation is also given. What is the other regression coefficient is the question. Isn't it very easy? Because we know that unless it is 0.8 into 0.8, you will not get the square root again as 0.8. Correct? Or else you can say 0.8 into 0.8 is equal to 0.8 square. Sorry, Byx, right? Into Byx is equal to 0.8 square. So what is the value? Straight away we can write what is Byx. 0.8 into 0.8 divided by 0.8. Hope all have got the answer. Yes, no. Is it I've got an answer here? No. What happened? The answer is 0.8. Yes, the answer is 0.8, and that too we need to be, yeah, okay, and we need to be very careful. Your what was the sign here? Let's take a note of the sign. They are positive, okay. You can also keep in mind 2-3 points over here. The answer is 0.8, and you need to remember that always their sign, always signs will be the same. They will never change, okay. Signs between what all? Correlation and regression coefficients. See my spellings? They're horrible. Always signs of correlation and regression coefficient, IENT, will be the same. Yes, yes, correct. 0.8 is answer. Good. Okay. Always the regression and coefficient correlation will be the same sign. They will not change at all. If you have one of the regression coefficients negative, the other one also has to be negative. If correlation is negative, then both the regression coefficients are negative. They cannot be of different signs. They're all always of the same sign, will be of the same sign. Positive means all positive. Negative means all negative. SIGN. Okay. Then another few points that you can remember is the regression coefficients are also related to standard deviation like this. The regression coefficient of y on x is defined as r into standard deviation y by standard deviation x, where r is our correlation coefficient. And regression coefficient of x on y, you can remember it this way: denominator is the second suffix. That's all you need to remember. See, byx, second suffix is in the standard deviation denominator. That way you can memorize them. Okay, I hope there aren't any doubts with respect to this, and let us proceed. And yeah, this is also just for information, how to interpret correlation and regression. So those are the few common questions that we have observed. Correlation and regression type, correlation and regression. Then maybe something with respect to scatter plot also are asked. What is scatter plot and what would be the pattern? You need to remember that our Carl-Pearson's correlation coefficient gives us only linear relation. It will assess only the degree of linear relation. It will not assess any other graph. If there is a non-linear regression, non-linear correlation between variables, Carl-Pearson cannot measure what is the degree of relation. Okay, it will measure only linear relationship between them, and depending on the values of the correlation, we generally, this is not a hard and fast rule, but this is a general way of writing: high, very high, then moderate, then low, or negligible or very weak correlation. Okay, positive or negative depending on the sign, and the strength of the relation, whether it is very high, moderate, low, or negligible, depending on the magnitude. And we know that value of correlation doesn't go beyond -1 to 1. Okay, then proceeding further, what is the next question? Which is the test, which is a kind of test that we can use from the following options? Which is a kind of test from the following options that is the right test to use when the hypothesis for testing are stated, when the test hypothesis is stated as like this. Okay, you are given the test hypothesis as population mean is equal to sample mean versus population mean is not equal to sample mean. Okay, so whether it is one-tailed test, whether it is two-tailed test, either of it or none of the above, which is your answer? Which is the answer for it? Which is the answer for it? This is an example of a two means test. I mean, a single means test. It's an example of single means test. I've got an answer. Hopefully it's correct. Oh no. This is not equal to is an example of two-tailed test. This is how we identify one-tailed or two-tailed. Okay. This is an example for a two-tailed test. Our answer should be B. I'll just confirm. Yes. Yes, B is the answer, correct. This is a two-tailed test, okay. Now it's correct. When do you get a one-tailed test? When your alternative is greater than or less than population mean, the sample mean. When you say that the sample mean is greater than population mean, or when we say that the sample mean is less than population mean, then we have the test which is one-sided. Okay, So alternate, it depends. It purely depends on your alternative hypothesis, whether your test will be one-tailed or two-tailed. So when your alternative is not equal to type, okay, when your alternative is not equal to type, then we have two-tailed test. That's all you need to remember. Very easy to understand. Whatever be the test, this is an example of single mean. You have only one mean and you're comparing with the hypothesis value. So this is a hypothesis for a single mean. Be it two means test or be it variance test, wherever it is, the rule remains the same. Whenever it is not equal to type of a data, whenever it is not equal to type of a hypothesis, it is called a two-tailed test, otherwise it's called a one-tailed test. Can we proceed? Identify from the following, from the following the test statistic which for which the value of the numerator should always be greater than that of the denominator. Value of numerator should always be greater than that of the denominator. From which of it does the value of numerator be always greater than that of denominator? If you had understood when we discussed the first few problems, then definitely you will have an answer for it. We did chi-square. We did one question based on chi-square. Later we also, previously we did an ANOVA. Okay. Z-test and T-test and the chi-square test, we cannot expect, or at least, in chi-square, it is the other way always. Your numerator will be smaller most of the time. If you remember F-test, what was it? F-test was sum of treatment divided by error, right? So it is only for ANOVA kind of a test that you can expect that it will be greater than that of denominator. Again, I being a statistician, I will not accept this statement to be correct. There are many situations where for a test statistic, you get F value less than 1. Being a statistician, I will not agree to this statement that numerator is always greater than denominator in the case of F value. I will, or again, like the second question that we discussed, here also I will tell there is an error in the question. Okay, but I don't know, I've always seen these kind of questions that are appearing in commerce and management streams. I can with 100% guarantee I can say that you cannot always justify it can be like that, because ultimately what is our F value? F value is the variance explained, MST divided by MSE, variation due to treatment by variation due to error. Okay, most of the time, or variation which is explained by a model divided by error. Okay, in simple terms, most of the time the formula for it works as MST treatment divided by MSE. Need not be always greater than 1. It can be less than 1. It can be any of the values. Only thing, it has to be positive. Never you will get negative values. That we can say. Chi-square will never be negative. F-test will never be negative. Okay, please keep that in mind. And this question as such, according to me, according to pure statistics, it is wrong. Okay, so the only assurance we can give is always positive statistic. Okay, always positive value for both chi-square and F. You will only know why it is statistic. Why is it like that? Because, just a moment, I'll just rectify the error. Yeah, why is it like that? Because chi-square, you remember the formula? O minus E square. Numerator is being squared. So there is no question of negative coming in. F statistic means sum of squares. Again, it's a difference that is squared. So both of it has got only positive terms in it. So your answer also has to be positive. It can never go negative. I hope I've explained it. And why I said the question is error is, it cannot be. Okay. But in Z and T value as well, you cannot conformly say that it will be greater than 1 or it can be less than 1. It can all change. It can also be negative. So for when some erroneous in this context, they will give full mark. Will they give full mark? you're stating it, I believe, Dr. Vidya. You're stating that in such context they would give full mark. Hopefully, they should be giving full mark if it is a question of that kind. And it was asked. It was asked in somewhere 2016 or one of those years, not very far from now. Okay, they were asked. Yeah. So next question is, which of the following tests can be applied to ordinal scale data? Sorry, can be applied to ordinal scale data. Which of the tests can be applied? Yeah, okay. The options have got many. Yeah. Which of the tests can be applied for an ordinal scale data? So when we talk about ordinal scale data, we need to remember that there is no point in finding mean, median, standard deviation, all that. Okay. So there are no parameters, there are no calculations involved in these kind of data. The data should always be based on count or rank. The data should always be based on count or rank. Okay. A very lighter scale that is. Hence, uh, other than Z test, we can apply all of it. Okay. So right now itself, you need to remember that these are, I'll discuss it. Maybe I can, maybe instead of writing, let me take you to the next slide. Yes, I have it here. A few of it are here. Yeah. Corresponding to the parametric test that we have in our, in the test of hypothesis, we also have non-parametric tests. Okay. So the common non-parametric tests are Wilcoxon's rank sum test, which is used corresponding to paired t-test. I know you all are aware of what is paired t-test. When you have, pre-post analysis, before an advertisement, after the advertisement, what is the impact? Pre-COVID and post-COVID, what is the change? So you should have the same type of people and you are having an analysis based on all of them. When you are having unpaired data, like, prior to or else, male, female, the difference between their salary, difference between their investment options, or if you want to find out two different companies and their behavior, and you're doing an analysis, in such cases we have unpaired test. And corresponding to that, when you're using ordinal data or when you're using some other kind of data which is not purely ratio scale, we go with Mann-Whitney U test. Then corresponding to our correlation by Carl Pearson, we have Spearman's rank correlation. Not only Spearman's rank correlation, we also have Kendall's tau rank correlation. Okay. Then corresponding to our one-way analysis, you have Kruskal-Wallis analysis. Then you also have Friedman's test. These are all the corresponding non-parametric options. I don't know whether I explained it properly. What is parametric, what is non-parametric? Okay, so in this case, Z test is actually a parametric test. Parametric test where you cannot use ordinal data. Ordinal data. Okay, Z test is based on normal distribution, and there are a lot of assumptions underlying whenever we are using parametric tests. Non-parametric tests are much easier to work with, much more liberal in their assumptions. They are not that very hard and fast rules, or very strong in their assumption. Same way, power of the test also reduces. We saw what is power, the ability of a test to reject a null hypothesis when it is wrong. That is the power. Power of the test also reduces when you go with non-parametric test. That one problem is also there. But to handle ordinal data, to handle the data which is of which kind of, which are not ratio scale data, we go with these kind of tests. Okay. So chi-square test is a non-parametric test. Kruskal-Wallis is a non-parametric test. Wilcox and Mann-Whitney is also a non-parametric test. All of them can be used for ordinal data. 1, 3 and 4 is the answer for it. If any clarifications, there are a lot of questions based on these tests. Okay, there are plenty of questions repeatedly asked. So if it is, so it's really good if you are clear about the various tests of hypothesis, the options that would come under that, or the variations of questions with that. If there is any doubt, please ask. Otherwise, let me proceed. Which of the following tests can be based on the normal distribution? Which of the following tests can be based on normal distribution? Yeah, now you can think over and tell me which can be based on normal normal distribution. Let me come back one slide before previous one. Z test is, this is a test that is based on normal distribution. Okay, this is a test that is purely based on normal distribution. So how do we use that normal distribution here? And now if I have any answer, then it is good. Let me check if there is any chat with an answer. Oh, sorry. My screen itself went off. No, there aren't any. Okay, then I think it is good if I explain. The answer is all the above. Okay, answer to this question is all the above. And just a moment. I'll just explain how or what are each of these tests. Okay, now let us see what are these various tests. So the difference of independent, now one of the important points with which you can understand whether it's a parametric test is this term means. Okay, this term means will help us to understand whether it is a test which is based on parameters. Okay, whenever the terms of these kind comes, we need to understand that they are all parametric test means. Another test that which doesn't actually have average calculation but goes with probability is proportion. Okay, proportion test is also based on normal distribution. Okay, so the common tests that are based on normal distribution are, okay, tests for single means, the common ones. Okay, we have learned in our PG programs. Two means, that means you're comparing two different populations with respect to their average. Okay, then we have proportion, single proportion has got Z test. Single proportion, the null hypothesis can be, one of the example can be, I want to know whether the proportion of literates in Bangalore city is, or illiterates in Bangalore city is 0.2. So that is a single proportion test. Same way we can have difference of proportion or two proportions, like two means. Okay, if I am comparing urban and rural Bangalore, okay, difference of proportion appears there. I want to compare whether the proportion of illiterates in Bangalore urban and Bangalore rural, is it the same or do they differ? When I am making a comparison of that kind, we can call it as a test for difference of proportion. So in all those cases, we have Z test. Okay, all of it is based on Z test. Okay, they are all the basic parametric tests. Apart from these parametric tests, you have tests for variance. You have tests for variances also, which is based on chi-square. So don't think that chi-square is always non-parametric. And F test, okay, F statistic calculation. F statistic calculation is also there. Chi-square tests are also there for variances. Okay, that is for single variance, we use chi-square test. Single variance, you don't have to remember all this in the sense exactly, but when it comes to the options, you will be able to remember, I believe. Okay, when you are comparing two population and the variances, when you are comparing two variances of two populations, we use F statistic, which we saw in our ANOVA, somewhere similar to that. Okay, single variance is based on a chi, but the formula, everything varies a lot. Only thing, this chi-square distribution will fit into a chi-square probability curve. That is why it is called chi-square test that is used. So it is different from our chi-square test for goodness of fit or chi-square test for independence of attributes. Chi-square statistic is used. That's all. Okay. I don't know whether I conveyed what was expected out of this question. I hope yes, and let me proceed. Another question can be from the following: identify one situation where F test cannot be used. F test cannot be used. Yes, it is related to the previous slide. It is very much related to the previous slide. Let us see the previous slide once again. Read the question properly. From the following, identify one situation where F test cannot be used. The options are to compare more than two population means. I've got an answer. It should be correct. Okay, let's read the options once again, ma'am. F test cannot be used. So when we compare more than 2 population means to test the hypothesis of single population variance, to test the hypothesis about 2 population variance, to study about randomized block design. Just one moment, coming to the previous slide. I said single variance is based on chi-square test. Okay, single variance is based on chi-square test. So you understood what is the option. Okay, here the answer is like this. And this is basically our ANOVA. See, more than 2 means ANOVA. I've got another answer now. Yeah, okay, fine. That's fine. That's not at all a problem. Not at all. After all, we are learning. Okay. After all, we are learning. So that's fine. Yeah. Single variance is chi-square. ANOVA is for more than 2 means. Up till 2 means you can accommodate with Z and T. Okay. T test and Z test will accommodate. ANOVA, which is based on an F statistic. F statistic. Okay, ANOVA's base calculation goes with a probability distribution called Snedeker's F distribution. That is why. And single variance is chi-square. Test the hypothesis about 2 population variance. Just now I said in the previous slide that is a F statistic calculation. And how about last one, randomized block design? Randomized block design, completely randomized design. These are all types of ANOVA. Okay, these are all applications of ANOVA. This is called designing an experiment wherein you can apply one-way or two-way ANOVA. RBD, CRD, etc., LSD, Latin square design, they are all the way how we can design an experiment, like how to collect a sample. First, you will define the population. From there, you will pick up a small sample. In that sample, how are you randomly allocating the questionnaires or treatments, whatever it is to be done? So these are basically called designs of experiment. And this is an extension from ANOVA. Extension from ANOVA. Application of ANOVA directly goes with these kind of designs. Okay. So when we learn in statistics, basically first we will learn all ANOVA and all its variants. Then we will go with design of experiments and see how ANOVA can be implemented in these designs. Okay. So the other designs are completely randomized design. Another design is called a Latin square design. These are all the various designs which are RBD. This is RBD, randomized block design. These are all various designing of experiments. This is not only for field experiments. We can do it in our sensors, in our sampling designs as well. Okay, so the answer to our question is B. Answer to our question has to be B. We'll just confirm and then proceed. Okay, then proceeding further. Oh, okay, we need to go a little more faster. I'm left with, we are halfway through, that's all. Okay, that's fine. Now we have done with the main concepts explanation. Now onwards, I need to see some answers. Okay, I need to see to it that you are able to follow also. The question here is, which statistical test should be applied to test the effectiveness of special coaching on marks of marks scored by the students? Effectiveness of special coaching on marks scored by students. How do we get the answer? It is special coaching. So we need to focus on a specific group, right? Which test would be most applicable here? I've got 1 or 2 answers. So let me see. I doubt that's correct. Yes, that's a correct answer. Mr. Ramesh has given the correct answer. Paired t-test. Paired t-test is to be used because you should be able to go with the same group. You should be able to, focus on the same group. Prior to the special coaching, they should be undergoing a test. They should be given a test. Marks taken care of. Then give the special coaching. And then you again give a similar test, not the same thing, because memory always affects us. Give a similar test of same difficulty level. That is how you go with, you understand the effectiveness of a special coaching. The term effectiveness you can see. Okay. So one of the ways with which you can find the effectiveness of a coaching is you should have the same study group, pre-coaching, post-coaching, data is collected and we are analyzing them. Okay. A paired t-test is a pre-post or intervention analysis. This is an intervention test. This is a test which is used to analyze the effect of an intervention, basically speaking. Okay, effect of an intervention. So here the special coaching is our intervention, right? Okay. Chi-square test, there are multiple of it. Chi-square test basically is used for a test for independence. Since we are here in the slide, let us see all of it. Test for independence of attributes. 2 attributes, not many. Independence of 2 attributes. Okay, 2 attributes in the sense whether color of a vehicle is influenced by gender. Okay, job whether the type of job like a desk job, traveling job is influenced by gender, whether the type of job is influenced by the locality where you come from, whether you prefer government job or private job based on from where do you come from, whether it's rural or urban, like that. If you're trying to find the independence of 2 or more 2 attributes, you can use this. It is also used for goodness of fit, to check whether a specific model or a theory fits in well. Okay, goodness of fit. And one of the parametric tests also, that is single variance. Single variance. These are the common uses. Apart from that, there are many. Okay, when you go to logistic regression, model fitness, everything we use, there are plenty. But according to my opinion, when I have checked all the question papers, I find the elementary starts only. So never it is going to a level beyond it. Okay. So Z-test is a pure parametric test which can be used for, we saw just a few minutes ago, we saw single mean, 2 means, proportions. Okay, so let me simply put it as means and proportions basically. Okay, means and proportions to test. Okay, and F-test maybe more than 2 means, that is first application. ANOVA, when you have more than 2, that is 3 or more goes with it. It is also used for comparing variances. Okay, it's also used for comparing 2 variances. Where else? It is also used in ANOVA. When I say, please remember that it is very much used in model fitness, goodness of fit, say regression or all the parametric models which we generate using softwares generally, not manually. When we generate, we find that it is F-test that is very commonly used. Okay, proceeding further. I hope I have explained all the questions and also the answer, and it was convincing. Let me proceed to the next one. That is, in a linear equation a plus bx, what does a refer to? What does a refer to in this? Slope, intercept, dependent variable, independent variable. A is A is not A is intercept. A is intercept. B is slope. Okay, B is called slope. B is slope. Okay, that is the rate at which the line grows. Rate at which the line grows. That is called slope. The level. If B is small, the line will grow very slowly. When B is large, the line will grow faster. If B is negative, there will be a negative growth for the line, right? So thereby it is at which the rate at which the line grows or falls. Okay. In y-intercept is called A, because when x equal to 0, what does it mean? When x equal to 0, what is y? That is the meaning of intercept, right? When what is the value? When x equal to 0, this term will disappear, correct? This term will disappear. Then what is left? A. That is means what? Where does y lie when x is absent? Okay. And which is our dependent variable here? Obviously it is y. Which is our independent variable here? Obviously it is x. According to X, Y varies. C. No, there were a few guesses which went wrong. Answer is actually B. Okay. There were plenty of guesses that came in, but the answer is B. Y-intercept. Is it fine now? Did you understand? When I say A plus BX, let it register in our mind now itself. A is intercept and B is slope always. Okay. And left hand side is dependent, X is independent. As X varies, Y will also vary. How will Y vary? Y will vary at a rate of B. Okay. And when X is absent, it's like, when you don't have income, what is your expenditure? It is not that we are not having any expense. We will have expense, right? So what is the bare minimum expense that we will have when you don't have any income? That is A. Then as you start earning, your expense will keep growing. That way you can remember. Okay, for intercept. I hope I've explained everything with respect to this straight line. And did I miss anything here? No. Yeah. Proceeding. Consider the following tests. Which of these are parametric tests? Now I'll not give the answer for sure. Okay, I want to answer from you all. Let me take a breath by then. Consider the following statistical tests and which are parametric. F test, T test, Z test, chi-square test. Answer, answer, answer. One. When I'm getting different answers, that is when okay. So everybody is agreeing to what Mr. Ramesh says. He said C. Is it correct? 1, 2, 3. Perfect. 1, 2, 3 are parametric. Excellent. So what I said prior to this is that is registered. I'm happy. Yes. F test is parametric. T test is parametric, and Z test is also parametric. Chi-square test is the non-parametric test. Okay. Why we call it parameter and non-parameter? There is a slide that is coming up, so I'll explain it. Maybe I can that time come back to question number 20, slide 27 once again. Okay, let me proceed. The difference between sample statistic and here only. No, yes, here I would also like to explain. Yes, the difference between sample statistic and its corresponding population parameter is sampling error, measurement error, coverage error, non-response error. Before we discuss this, I think it is good to know what is sample statistic, what is parameter. Okay, so both those questions would be, even the previous slide I would like to explain with this. Parameters and statistics are two functions, very, very common. Statistic, it's not the subject statistics or the discipline, it is statistic. They both are mathematical functions. When we talk about the entire population and we say population mean, population standard deviation, population correlation, population variance, all of it are called parameters. Parameters are most of the time we cannot find the value. Parameters, we will not be able to find the value of the parameters most of the time. We will not be able to calculate the value of parameters most of the time. Hence, what we do, we resort on a small sample. We will collect sample and corresponding function we will use in the sample statistic. Okay. So, a statistic is a corresponding function in a sample. Say, for example, for your population mean mu, you have sample mean x bar. For population standard deviation sigma, it is sample standard deviation S. For population proportion capital P, you have sample proportion P hat. For population value capital N, you have sample statistic value N. So what is this column completely is a statistic and this is parameter. Now the difference between them occurs just because of sampling error. When that will not be because of measurement error at all, nor coverage error. That difference is called sampling error, because obviously any type of difference that we expect from a calculated from a sample generally can be due to sampling error. There is a difference between sample statistic and the population parameter, basically due to sample error. Measurement error, coverage error, non-response error cannot be considered as the difference between population and sample. Okay. And coming back to the previous question, when I said parameters, I hope now you remember that F-test is a test that is used for means. T-test is also used for means. Z-test is also used for means and proportion. So they are all parameters. That is the reason why they are called parametric tests. Okay. And in chi-square, even though it is used for variance, mainly it is considered for test for independence. Basically, whenever somebody says about chi-square, the first point that comes to our mind is test of independence of attributes and goodness of fit. These are the two tests that are generally associated with chi-square, where there is no parameter involved. It is count. There is no parameter, rather it is based on only frequency. Okay, so that is the reason why it is called non-parametric test, based on frequency. Okay, yeah. So that was the explanation for it, and I hope you understood what's the difference between population parameter and statistic. And the difference between population parameter and statistic basically comes due to sampling error, and it is because of that reason, it is because of this reason that we run, this is the reason why we run tests of hypothesis, to run tests of significance. We need to confirm whether there is an actual difference or whether it is a sampling error that is causing the difference. Yeah, these kind of match the following. I saw a lot of question papers having at least one question of match the following. So let's see how much can we match. I don't have the option of annotating here. I don't know why. Usually there will be an option for me to insert. Yeah, this will probably help me. Okay, level of significance. Is it sample mean equal to population mean? Parameter, type 1 error, standard error. Level of significance is the probability of type 1 error. Okay. Can we stop our choice? No. CC, there are two C's. Look at the code, there are two C's, so we cannot stop with one option. Second one, standard deviation of a sampling distribution is standard error. Okay, where is this line? Let me copy this line once again. Yeah, standard deviation of a sample distribution is called standard error. So that's enough. Now we got the answer remaining CD. So it has to be B. Remaining we don't have to check. So whenever there is a match the following, try to match minimum and get the answer there. Okay. However, I hope you understood standard deviation of a sampling distribution is called standard error. That is something that you need to remember, because every time you do SPSS statistic using any of the software, first column will be coefficient, second column will be standard error. So that is the standard deviation of the calculated value. Standard deviation of a calculated value is called standard error. Standard deviation of a calculated value. Direct raw data, you know how to calculate standard deviation. When you are calculating standard deviation of a function, it is called standard error. Remember only that much, okay? Standard deviation of a calculated function like mean, correlation, etc. So even variance, anything, okay, anything you calculate and you're calculating the standard deviation of those functions, then we call it as standard error. Then we call it as a standard error, SE. Okay, fine. Now let us see the remaining two also. Numeric values that describe the characteristics of a population. Just now we saw. What are the numeric variables, values that characterize a population? They are called parameters, right? They are called parameters. Correct. This is same as B. Then normally distributed population, sample mean will be equal to population mean. In a normal distribution, sample mean will be equal to population mean. Fine. Proceeding. If there is any clarification or explanation required, please let me know. Otherwise, let me proceed. Proceeding to the next question. Yeah. Kendall's coefficient of concordance is used to, you remember previously I told you what is Kendall's test or Kendall's coefficient? Yes or no? Spearman's and Kendall's rank correlation, it's called. These are two non-parametric, oh, why is my spelling going like this? Relation, yeah. These are two methods of finding correlation of ordinal data for ordinal data. Otherwise, we use Carl Pearson's. So we know why do we use correlation? Now you got the answer. You may give me the answer. They are two different, okay? Don't get confused. Spearman's coefficient is totally different. F-F-I-E-C-I-E-N-T coefficient, spelling is wrong. Coefficient. Yeah, now it's fine. Why am I not getting any answers? It will not be taking the difference between two set of data. It will not be comparing variance. It will not be testing randomness also. Rather, it will be going with relationship. That's why I said correlation. Kendall's correlation. Okay, remember it that way. Kendall, Spearman, Carl Pearson's correlation. All three of them are used for testing relation. The difference from Carl Pearson is that Carl Pearson is used for ratio scale variables, pure numeric data like salary or import export or price of commodities, height, weight, all measurable data we use Carl Pearson's. Non-measurable ordinal data or even interval scale, it's better to go with Spearman's or Kendall's. Okay. Okay, so we have that's the same thing. Yeah. Since there aren't any questions, let me proceed. Did we see the answer there? No. Okay. I hope I explained it. Proceeding to the next question. Which of the following softwares are used for data processing? Which of the following softwares are used for data processing? MS Excel, Access, SPSS, STAR, and PASW. Should be known to everyone. All of you all should be, quite young also, I'm sure, that you would have already started your research work and learned a lot of Excel and Access. Excel Access we learn in school. What is SPSS, what is STAR, and what is PASW? I think STAR I haven't mentioned. Since I am not getting any answers, let me show you what are they. And yeah, I've got an answer. That's what I'm waiting for. D is our new SPSS. STAR is the answer. 1, 3, 4, 1, 3, 4, and even P 5 also. 1, 3. Where is it? 1, 2. Oh, what are the options here? 1, 2, correct. 3 is also correct. 5 is also correct. Yeah, 5 also. 5 also. 1, 2, 3, 5. A should be the answer. Okay, because Excel and Access, they both are Microsoft products which are used for generally data report generation analysis. Then comes our PSPP wasn't there, no? PSPP is like SPSS free version. PSPP is SPSS free version. So that was not there. Sorry, I mentioned it. That's all. MS Access and MS Excel is gone. Okay, so that is not that is definitely yes. MS Excel. They both are there for data analysis. SPSS, yes. PASW is a recent addition or a few years back of once IBM took it and then they started using it for analytics rather than just for research purpose in a full swing. They named it PASW. SPSS was called Statistical Package for Social Science. It's mentioned here, Statistical Package for Social Sciences. Whereas they have made it a little more industry oriented, calling it as predictive analytics software, PASW. So that is also a thing that is used for, that is also a software that is used for this itself, for data analysis itself. STAR is a different software which is not used for data analysis. So I think it is good to have an idea about R, Python, which are the other sources also, other data processing softwares too. It will be good. You might have already discussed in your the other class, in your communication, I mean your IT class. Okay, otherwise also have a look at it. All those numeric, which are the ones, same way which are the softwares which will help us in improving the reduce plagiarism. There are so many tools that are available which will help us in changing the language. Like those things are of help. Okay, that might help us. How much time are we left with? I'll quickly go ahead. Remaining are simple. Okay, you will be knowing. Yeah, this already we saw the slide. Then one of the classification. I think I'm coming to the end. Closing. Oh no. Okay. Okay. Sir, Babu sir, are you there? Can I take another 5 to 10 minutes? I hope participants will be fine with it. Or even Hari Bhaskar sir, can I proceed for another 5-10 minutes? Is it okay?
Yes, ma'am. Yes.
Okay, yeah, because a few more concepts are slightly different
Yeah,
from
okay, ma'am.
what we have done are there. That's why, okay. So it
Yes,
might
ma'am.
be of help. Yeah, I'm sorry that I'm exceeding the time.
It's okay, ma'am.
However,
No problem.
yeah.
Yes.
So the next one is what is a classification? Sorry, yeah, there is a chat too. Yeah, okay. Thank you. Yes, Sonia ma'am, I didn't know that you're there. Yeah, in the case of classification of data, the class has an upper limit is treated as the lower limit of the next class. What is it called? The meaning is that if I say 0 to 5 and the next class starts from 5 to 10, this is the meaning. And then it goes from 10 to. So what is it called? This is called an, why is it 25 coming here? Yeah. What's the answer? These kind of classes are called, in this case, read the question. The class having its upper limit is treated as the lower limit of next class. See, the upper limit is the lower limit of the next class. In such cases, we call it as exclusive type classes. You know why it's called exclusive type classes? Here, 5 is excluded. 5 is excluded and up to 4.9999 is included there. Okay, but 5 is excluded. That is the reason why included. Okay, that is the reason why it is called it's called exclusive type classes. You can remember that way. Okay, this is called exclusive type classes. So the answer is 3. Answer to this question is 3. Fine. The meaning I have explained. I hope you have understood also. The reason I have explained why it is 5, the upper limit. Okay, upper limits of all classes. Not only here, all the classes are excluded from the corresponding class. That is why the name exclusive class. So we know what is inclusive class. How will it be inclusive class? Inclusive class is like 1 to 10. Then I have 11 to 20. So my upper limit will not coincide with the next lower limit. Upper limit is 10, doesn't be the same as the next lower limit. There is a break. Okay. Then what is open end class? What is open end class? Open end class, if I am writing 20 and more, this is called open end class. Let me not confuse you. Here, let me give a bifurcation. Yeah, that's fine. Yeah, this is an example for inclusive type class. 110, 1020 is an example for inclusive type class because 1 and 10 both are included in the class. 10 and 20 both are included in the class. Now, what is open end class? When one of the ends of the class interval, 1 to 10, 10 to 20, 20 and more. So there is no upper limit here. Okay, when there is no upper limit, we call it as open end classes. No upper limit. Same way, it can be even lower also, lower end. It is if I am calling less than 1 and starting. So there is no lower limit. Sorry, it can be like this also. So when we call open end class, it can be any one of the end of the frequency table is open. Not necessarily both ends are open. One of the end is left open. That is called open end. So then if you know what is open end, then you also know what is closed end class. Okay. So I have explained all 4 of it now. Then proceeding to the next one. For a standard normal probability distribution, mean mu and standard deviation sigma r, obviously this one, okay, this you can learn it by heart. It is also indicated as n0, 1. This is an indication of a z distribution. Standard normal distribution is usually, till now we kept on talking about z-test, right? Z-test. Till now we kept on discussing on z-test. That is based on this standard normal probability distribution. The entire calculation or the entire probability table is probability distribution is standard normal probability distribution. And the best benefit of probability distribution is that its parameters, mean and standard deviation, are fixed. It doesn't vary at all. Okay, that is why it is usually denoted as N01. Mean is 0, variance is 1, or mean is 0, standard deviation is 1. Okay. I found some chat. I hope it is okay. Thank you for extending. Okay, that's a little encouraging. Thank you, sir. Thanks a lot. Yeah, okay. Then proceeding, we are, there is a very high inverse. Yeah, read this question properly. There is a high inverse relation between measures of overweight and life expectancy. There is a high inverse relationship between overweight and life expectancy. Which of the following statement of the coefficient of correlation is consistent with the statement? There are two information here. High is one information. Okay. Inverse is the second information. Use both of it and then decide which number is most suitable for the scenario. When we say relation, we know we are talking about correlation. And high correlation, the value should be more than 0.7. High correlation, the value should be more than 0.7. Inverse relationship, the sign should be negative. Direct relation, the sign should be positive. Okay. One moment, quickly go to that slide where we saw the relationship between, yes. Remember this? High is 0.7 to 0.9. See, if it is inverse or negative, they will have minus sign. If it is positive, it is sign is positive. When we say 0.5 to, this is not hard and fast rule. Please don't take it like that. You can even call it as, 0 to 0.4, 0.4 to 0.8, 0.7. 0.7 above is strong. That you have to remember. 0.7 above correlation is strong or high. Okay. I hope I can get an answer now. You would have already figured out what is the answer, which was our question. Where were we? This was done. This was done. Yeah, my slide has become so untidy. Oh, how come I missed one? I have missed one. Yeah, we'll come to it. We'll come to that slide. That's fine. Yeah. So what's the answer? Did I get any answer yet? No. High and inverse. Obviously, answer has to be due to lack of time. Let me not wait. It's minus 0.8. High and inverse answer. I am sure you would have given D as an answer. Inverse means negative. Inverse means negative. Okay. That is why I said inverse means negative. Okay. Good that you gave a answer so that I understood you haven't. I haven't explained it properly. Direct means positive. Relations, direction, and strength is explained. Okay. So this gives the direction of the relation, inverse or direct. And strength is this high. This is the strength of the relation. This is the direction of the relation. So the answer is D, 4. Okay, I can't see the charts now. Yes. Okay, fine. Yeah, good. One more this thing is there. What is it called? Match the following. Standard error of mean. Did we see this? No. Standard error of mean. Now you should be knowing. Standard error of mean. Just now, see, these are concepts that you need to remember. Okay, there is no question of forgetting or there is no question of changing of definition. It's fixed. So let me come with my arrow mark. Yes. Okay, so standard error of mean is standard deviation of sampling distribution of mean. That is fixed. So 1 to 4. Is there any question? 1 to 4? Yeah, there are two options with 1 to 4. 1 and 3. Okay, so definitely we can rule out these two. Okay, this is not there. This is not our option. Nor is, let me not do that. Yeah, nor this is an option. But between 1 and 3, make a decision. Base of point estimate. Where is the point estimate of the mean of the population is mean of sampling distribution. Point estimator of mean of population. Mean of population is mean of sampling distribution. It has to be 3. Oh, that is also fixed. No choice. Okay, so forget the second one. Third one. No, non-specific hypothesis means, yes, here you can have a clarity. What is it? We saw, no, what is one-tailed and two-tailed test? What is it? When you are not sure whether it is greater than or less than, it is an alternative hypothesis of not equal to type. Okay, and parameter value of descriptive statistic is corresponding to mean. Okay, so parameter value is value based on all observations, all observations. Yeah. So D is 2. Yes, so what is our answer? Answer is 1. Answer has to be 1. Am I right? 1 to 4, 2, then 1. 3 is 1. 3 is 1. C is 1. Yes. C is 1. Yeah. Done. I've got a few answers here. So let me quickly check. Sorry. I think I skipped from the slide. Okay. I'm sorry for that. Something has happened. Yes. Correct. Yeah. Now let us quickly go ahead. Next one is this. Same way. Quickly you can say now. Chi-square test. What is chi? Any one or two you let us figure out because they are distinct answers. Chi-square test. Test of significance of means. No. Goodness of fit. Difference of mean. Test of difference of means. So 1 chi-square and goodness of it. A to 2. A to 2 is fixed. A has to be 2, which is option A to 2. Done. That's all. 4. 4 is our option. We don't have to even look at the rest of it. It cannot be any other option. It has to be the same. Okay. But I'm sure. Yes, correct. Thank you. That's the correct answer. We don't have to look at. But please use this answer to remember further what is it used for. Okay. Difference with this slide we have discussed quite a lot, so I don't think I need to wait there. A scale of measure which has no order, distance, unique origin, which has no order, distance or unique origin is called the least weightage one, which is on nominal scale. Obviously nominal scale doesn't have any scale, no order, nothing. You can call one as A, another, you can call one as 1, another one as 10, another one as 200, no issues, doesn't make a difference. But order scale, order matters. Interval scale, distance, not, I can't say it matters, but at least there is some sense when we make the interval. We don't randomly put some numbers. We will at least say -1, 0, 1, or we will say -2, -1, 0, 1, 2, or we will say 1, 2, 3, 4, 5. So the order has some significance. So nominal scale is the only scale of measurement which doesn't have anything to do with order, distance, or origin at all. Okay, that's the least or the most crude form of scale. Yeah. Then Sturge's rule. Sturge's rule is the rule that is used for, in softwares, when you ask for histogram, when you ask for frequency tables, it comes by itself. It comes by itself, right? So basically it is based on the Sturge's rule, which we don't manually use much because taking log is difficult. What is the formula? You may try to remember the formula. 1 is the answer, okay? 1 plus 3.322 into logarithm of n is the formula with which we will calculate how many classes do you require. How many, in a histogram or a bar chart, how many bars do you require? That is decided by Sturge's rule. And this is the algorithm which is used in all the softwares. Okay, because of ease of calculation, we go with a better way. What we do, we will take the last value and the highest value, maximum and minimum, take their difference, decide how many classes you want, and then proceed with it. We decide about the number of classes and then we see what is the interval when we do manually. But in softwares, the algorithm is based on Sturge's rule. Answer is 1. Okay, it's an image because I couldn't type in. I didn't get time to type in. Rather, I took, this was just previous year's question, I think, or 1 year back. That's all. Okay, so please make a note of it. Sturge's rule, the formula is a straight one. A 1 plus 3.22 n. Then what is the, which of the following is not a characteristic of normal distribution? Okay, good question. So that you will learn all the characteristics of a normal distribution. Bell-shaped and symmetric, yes, normal distribution is always known for its bell shape and its symmetry. Whenever there is symmetry, mean will be equal to median equal to mode. So 1 and 2 are the properties. I've got an answer already. It must be correct. No, mean, median, mode are equal. Ma'am, take 1 and 2 together. Whenever there is symmetry in a distribution, mean will be equal to median will be equal to mode. Whenever there is symmetry in a distribution, mean will be equal to median will be equal to mode. Okay. Then total area under curve of a normal probability distribution is 1. Yes. Total area under the normal probability curve is 1. Okay. And the two tails of the distribution in both the direction touches the horizontal axis. No, it doesn't touch the horizontal axis. In fact, this is how a normal distribution goes. If it is drawn symmetrically, you will always see that the line is like this, axis goes like this. It will never ever touch the x-axis. It is called an asymptotic touch. It will go to infinity somewhere and then only it will touch. Okay. So the answer to the question is D. It will never ever touch the horizontal axis. At the same time, please use this question to remember to analyze the properties of a to analyze the properties of a normal distribution. Earlier we saw standard normal distribution has got mean 0, standard deviation 1. That is standard normal distribution. Okay. This is just normal distribution without standardizing. Now, how do you standardize a normal distribution? It is simple. Standardizing a normal distribution is just like, let me use a text and then write it. It is just x minus mean divided by standard deviation. That's how we will be getting z, our standard normal distribution. So if x is a variable which is normal, z is defined, standard normal variable is defined like this. If x is a variable, then standard normal variable is x minus mean by standard deviation, which will follow LLOW, which will follow N01, 0, 1. Yeah, that's it. That is a standard normal distribution. What we saw just now is a general normal distribution, not constant mean and variance. And then, now this would be known to all of us. If the equation y equal to 5 plus 0.6 was graphed, the slope would be, I'll be very happy to see a correct answer. The vertical intercept would be, slope would be plus 5, slope would be plus 6. Here can we see what is, either give me an answer or give me the options. Intercept is always A, correct? That is 5. Slope is always B, that is 0.6 positive. So the slope should be plus 6, D. Okay. This is also a recent year's question, so please be careful about it. I hope I have explained it. Yeah, this is about D. D is the answer. Correct. Very good. D is the answer. Then, which is not a part of control chart. Control chart is x bar r sigma c. X chart. X chart is not a control chart. C chart. Product control, process control. C chart is not a part of control chart for variables. Yeah. There are two types of control charts. One is called variable and the other one is for attributes. Okay. So variable, you can calculate x bar, mean, r, range, sigma, standard deviation. So all three are for variables. C is the number of defects. So since it is number of, it is not a measurement, it is a count. So the answer is again D here. Okay, it's given over there. Yeah. And decision making, this is very first time I'm seeing a decision making question coming in into the picture, very first time. Generally operations research kind of questions are very rare. So let me explain it. Decision making under uncertainty is when we are totally unaware of the outcomes. Okay. Decision making under risk is when probability is known. Decision making under certainty is when we are very clear about the outcomes. Okay, where is my, okay, copy this and then put it elsewhere and then take it. Yeah, under certainty means we know what are the strategies and we are also sure about the outcomes. Okay, and decision making under uncertainty is when we have Okay, I'm not getting that chart once again. Sorry. Yeah. Decision making under uncertainty is when outcomes of the probabilities are not known at all. When we know the outcomes, but probability is unknown. Okay. So A to the B3 and A2 under certainty. Yeah. A2 B3 C1. A2 B3 C1. B is the answer for it. I think you all have already got the answer for it. Yeah. Whenever you have the answer is B. The answer should be B. Certainty is when we know very clear what are the strategies, what are the outcomes, we are sure. Risk involves probability. Remember only that. Risk means there is probability involved. A to, okay. I'm sorry, sir. If I said A as 3, no, decision making, I'm sorry. Decision making under risk is 3. B is 3. I'm sorry. I think I said A3. I'm so sorry. Risk is 3. Okay. B to 3. Risk taking with probability known. Certainty, we are very sure about the outcomes. A to 2, B to 3, and C to 1. Okay. Once again, certainty means we are sure about the outcomes also. Risk means we only know the probability of outcome. We are not sure which will happen. Uncertainty means we don't even know the probability. We are totally clueless about what would happen. Okay, like the present scenario. That's it. That's it. I have covered almost all the concepts except for one slide over here. So I shall I shall provide this question. I mean slides also to sir, either Babu sir or Sonia ma'am or anybody. And I have a set of notes as well, which was prepared earlier for net class. So both of it, I shall share it today itself to ma'am. I'm sure ma'am will be sharing it to you. Thank you so much for your patience. In fact, I exceeded the time by 20-25 minutes. I'm sorry. I exceeded, but then I hope I served the purpose of it. If with solution and explanation, I shall try to, yeah, the same PPT with solutions as much as possible, yes. Slide with the answers would be better, I think, right? Yeah. Thank you all. Thank you so much. Thank you, Sonia ma'am. Thank you, Babu sir, and I forgot sir's name. Yeah, I think I can wind up. Can I?